What if I told you that right now something is moving through our solar system that shouldn't exist? Something that's breaking the laws of physics as we know them? Something that might not be natural at all. On October 27, 2025, NASA captured images that made every scientist in the world stop what they were doing. What they saw was impossible. And yet, there it was. Clear, measurable, undeniable. This isn't a movie. This isn't speculation. This is happening right now. And what comes next could change everything we thought we knew about our place in the universe. Something extraordinary just happened with Atlas. After months of anomalous behavior that defied every known law of physics, the most mysterious interstellar object in history has finally revealed what scientists have been desperately searching for: clear evidence of non-gravitational acceleration. This isn't just another strange measurement. This is the smoking gun that could definitively prove we're dealing with technology rather than a natural object. When NASA's Punch satellite constellation captured those images on October 27th, the global scientific community was left stunned. Atlas was performing maneuvers that gravity alone cannot explain. According to David Farnovia, navigation engineer at NASA's Jet Propulsion Laboratory in Pasadena, new data shows that when Atlas passed extremely close to our star, it appeared to be accelerating slightly faster than expected. The extra push is extraordinarily small, microscopic by any human standard. To put this in perspective, it's like detecting that a car traveling at highway speed is accelerating by the width of a human hair every hour. But here's what makes this discovery revolutionary. This level of precision in measurement means we can now definitively say that Atlas is not following a purely gravitational trajectory. Then came the impossible brightness surge. Just before reaching perihelion, Atlas suddenly began brightening at an unprecedented rate. Its brightness increased approximately in proportion to its distance from our star, raised to the power of -7.5. In simple terms, as the object approached our star, it became much brighter than scientists would normally expect based solely on distance. Such extreme brightness has never been observed in any comet within our solar system. This rapid brightness increase could mean one of two things. Either the object is releasing massive amounts of gas and dust, showing unusually strong activity, or it has a very unusual chemical composition that reacts intensely to solar heat. What makes this even more intriguing is that Atlas had shown the same strange behavior previously when approaching Mars. At that time, it suddenly became brighter as it neared the planet. Now it's doing it again, showing a sharp and unexpected brightness increase just before its closest approach to the Sun. This repeating pattern suggests we're not dealing with random natural phenomena, but with consistent, predictable behavior. Exactly what you'd expect from a controlled system. During its journey through the solar system, Atlas has displayed several behaviors that simply shouldn't exist in nature. For a long time, it showed a tenuous stream of dust that appeared to point toward our star, the exact opposite of what comets do. Just before perihelion, this anti-tail turned and transformed into a normal tail. Light scattering around the object showed strong negative polarization, an effect never seen in any comet before. The layers of gas molecules around Atlas appear to form a type of protective shell, which was completely unexpected. Inside that shell, instruments detected layered composition zones. The inner region dominated by nickel with little iron, an intermediate layer rich in cyanide compounds, and the outer envelope dominated by carbon dioxide and carbon monoxide. The best image of this interstellar object was reportedly captured by the HiRISE camera aboard the Mars Reconnaissance Orbiter on October 2nd when Atlas came closest to Mars. Those frames, according to multiple sources inside the scientific community, show hints of linear structure and shadowing inconsistent with random geology. NASA has not released the highest resolution images publicly, citing internal review and verification needs. That delay has only heightened speculation. If the images are unambiguous, why withhold them? If they're ambiguous, why not release them and let independent teams evaluate? Atlas entered the solar system from the direction of the Sagittarius constellation, the same region of sky from which the famous and mysterious WOW signal was detected in 1977. That signal, a narrowband burst at hydrogen frequency, has been a perennial puzzle. The directional coincidence is uncanny and cannot be dismissed as simple coincidence without careful statistical evaluation. When combined with the motion and composition anomalies, the connection adds weight to the possibility of an engineered origin. Scientists have tallied multiple anomalies and placed Atlas at a 4 on the AV-Loeb scale, one step shy of confirmed artificial origin. The list is long and statistically improbable. The first anomaly is its trajectory. Atlas travels within 5 degrees of the ecliptic plane where the planets orbit. The odds of a random interstellar object arriving along this plane are vanishingly low, on the order of 0.2%. An object from another stellar system should approach from a random sky position. This alignment reads like a corridor someone or something selected. The second anomaly is the physics-defying jet. In July and August 2025, Atlas released a jet of material directed straight toward the sun, opposite the behavior dictated by solar radiation pressure. All observed comets have tails and jets pushed away from the star. Atlas produced directed emission toward it. That contradicts our basic expectations of how sunlight interacts with dusty, icy bodies. The third anomaly involves size and speed. Atlas's inferred mass and cross-section place it far above objects like Oumuamua and Borisov, yet it travels faster than either. 1,000,000 times the mass of Oumuamua combined with sustained high velocity is inconsistent with common ejection models from stellar systems. The energy required for such motion is extreme. The fourth anomaly is timing. The object's course brushed close to Mars, followed by paths near Venus and Jupiter, and yet it remained largely undetectable from terrestrial telescopes during critical moments. The precision of those encounters suggests predictive plotting rather than random drift. The fifth anomaly is industrial composition. Spectroscopy reveals an unusually high nickel-to-iron ratio, more akin to refined alloys than primordial meteorites. Natural formation typically yields far more iron than nickel. The observed ratio hints at material processing beyond typical cosmic fractionation. The sixth anomaly is dryness. Classic comets are rich in water ice, often 80 to 90% by volume. Atlas shows only about 4% water content. It is drier than many of Earth's most arid deserts, yet it demonstrates behaviors similar to active comets, such as transient jets and brightness bursts. How can such a dry body mimic comet-like activity? The seventh anomaly involves polarization. The object's scattered light exhibits a negative polarization curve, unlike anything cataloged in decades of comet and asteroid observations. Fingerprints in polarization space do not match known mineralogical or dust mixtures, suggesting surface textures or materials foreign to our catalog. The eighth anomaly is the WOW direction. The directional tie to the 1977 WOW signal remains statistically striking. If that earlier signal and Atlas share a common sector in Sagittarius, the coincidence invites deeper inquiry into that stellar neighborhood and its possible role in interstellar signaling or object ejection. The ninth anomaly is apparent temperature. Observers report that certain emissions from Atlas are bluer than the sun in measured bands, implying thermal or emissive processes that produce effective temperatures higher than solar photospheric temperatures. Natural passive bodies should not manifest such relative blueness unless self-generated emission or reflective processes are present. When probabilities for each independent anomaly are multiplied, the combined odds of all of them occurring naturally drop precipitously, below the threshold where chance remains plausible. That said, extraordinary claims require extraordinary evidence. The leading natural explanation remains outgassing, sublimation of volatile ices acting like tiny thrusters. But the observed mass loss, thermal signature, and chemical tracers do not reconcile neatly with the thrust required to produce the measured acceleration. Some have suggested patchy anisotropic outgassing from localized, highly volatile pockets. Others propose exotic surface physics, materials that emit asymmetrically under solar heating. Yet each hypothesis strains to account for every anomaly at once: chemical composition, anti-tail dynamics, negative polarization, trajectory alignment, repeated brightness surges, and the directional coincidence with the WOW sector. On October 27th, the punch feed changed everything. Analysts saw a consistent, minuscule acceleration that did not match models of solar pressure, thermal emission anisotropy, or dust-driven forces. Reprocessing of raw telemetry and cross-checks against independent datasets produced the same result. Within hours, observatories from Mauna Kea to La Silla and radio arrays from Greenbank to Parks were retasked and synchronized. The signal remained. At JPL and other centers, teams reran orbital solutions, hunted systematic errors, and engaged in silent peer review. The mood veered between careful skepticism and a rare, palpable wonder. Veteran mission engineers who had shepherded rovers and orbiters through delicate maneuvers found themselves confronting data that suggested control, where none should exist. The brightness record deepened the mystery. Atlas's photometric light curve displayed periodic micropulses, repeatable bursts embedded in larger surges. Those microstructures implied either controlled venting or structured illumination. Radio observations revealed ephemeral harmonics and fleeting spectral features that resisted straightforward classification. Spectral lines were stubbornly atypical. Heavy metal signatures, dominated by nickel with suppressed iron lines, appeared alongside carbon monoxide and carbon dioxide in the coma. Trace cyanide signatures flared intermittently. These fingerprints read more like processed materials than unaltered primordial mix. Dust analysis during the anti-tail phase indicated a narrow particle size distribution biased toward submicron grains. That selectivity suggests filtration, engineered emission, or at least a non-random ejection mechanism. Polarimetric data produced curves inconsistent with terrestrial laboratory analogs. Researchers could not reproduce the exact phase angle dependencies using plausible mixtures of metal grains and organics. Rumors of classified high-rise frames, images showing rectilinear hints, linear striations and shadowing patterns fueled public debate. NASA's official stance cited verification and review. The reluctant public release only intensified speculation. If such frames reveal engineered geometry, their verification must be rigorous. If they do not, the process of open science will correct initial conjectures. Timeline and geometry matter. Atlas's path reads like a sequence of waypoints rather than a random track, near approaches to Mars and Venus. A tight pass during perihelion obscured from many terrestrial vantage points, and a trajectory angled to skim the outer bounds of Jupiter's influence. For those who work on guidance and navigation, such a corridor suggests planning. Hypotheses expanded. Some scientists propose a hybrid scenario, a derelict engineered object or a fragment of a larger construct retaining limited thrusting capability. Others explore new physics, anisotropic photon emission from previously unknown material phases, electromagnetic coupling to the solar wind, or photonic sail dynamics under complex illumination. A smaller set entertains more speculative mechanisms, internal energy generation, directed energy systems, or control through electromagnetic fields. Public reaction ranged from breathless headlines to sober expert analysis. Academic journals fast-tracked notes and letters. Universities convened emergency colloquia. Religious and philosophical communities debated implications for cosmology and human meaning. Governments quietly reviewed contingency plans and data-sharing protocols. The scientific response is methodical: observe, model, and test. Radar ranging will refine mass and bulk density constraints. Thermal infrared surveys aim to detect excess heat indicative of internal power sources. High-resolution spectroscopy continues to map compositional gradients. Radio arrays scan wide bands for narrowband carriers or modulated signals. Any coherent narrowband transmission would transform interpretation overnight. There is caution in the chorus. The history of astronomy contains many anomalies that later found ordinary explanations. Scientists therefore demand redundancy, multiple instruments, independent analyses, and careful statistical framing before embracing extraordinary interpretations. Nevertheless, the opportunity is unique. Before it swings past Jupiter and recedes on a hyperbolic trajectory out of the solar system, Atlas will come closer to Earth than at any previous point in its passage. This makes the next observational windows critical. Hubble and James Webb observation slots have been scheduled. Ground arrays across continents remain on alert. Citizen astronomers continue to supplement the global data set. If Atlas executes another non-gravitational maneuver, or if instruments detect structured electromagnetic emissions, the evidence would be compelling. A sustained pattern of controlled acceleration, combined with engineered composition and repeating behavioral cycles, would be difficult to reconcile with known natural processes. The implications are vast. If artificial, we would confront an artifact of non-human manufacture, one that has passed through interstellar space and chosen a path through our planetary neighborhood. International scientific, diplomatic, and ethical protocols would need immediate activation. Preliminary protocols exist for data custody, communication, and verification. But no governance fully prepares humanity for verified contact with extraterrestrial technology. If Atlas proves natural but extraordinary, planetary science will require revision. Formation and processing theories for interstellar bodies would need expansion to account for engineered-like signatures arising from physical, chemical, or radiative processes beyond our current models. Either way, new missions will be proposed. Rapid response interceptors, dedicated deep space monitors, and expanded radio sensing arrays will move from speculative white papers into funded programs. Interdisciplinary institutes, combining astrophysics, material science, engineering, and ethics, will likely form to study exotechnology and its societal consequences. Prudent scientists also warn about confirmation bias. The temptation to fit data to exciting narratives is human. The best defense is transparency, open data repositories, blind analyses, and peer review. The community has committed to those standards even as public pressure mounts. For nights when the sky is clear, Atlas's faint glow will be a reminder that the universe still has surprises. Each new spectrum, each photometric pulse will be archived, analyzed, and debated. The object's subtle shifts will be treated like a foreign language for which we are rapidly building a lexicon. Communication attempts are discussed carefully. Some propose simple, unambiguous radio beacons, hydrogen line pings, or prime number sequences sent toward Atlas's incoming sector as a non-provocative test. Others argue for restraint, suggesting that any intentional signaling be multinational and transparent, reflecting a shared human choice rather than unilateral action. Ethical and policy questions are immediate. Who speaks for Earth? What messages are appropriate? How do we balance scientific curiosity with caution? These are not merely rhetorical. They will shape concrete, time-sensitive decisions if any sign of intelligence is confirmed. Technically, the signature that would force consensus is either sustained non-gravitational motion with no plausible natural driver, or the detection of narrowband modulated radio emissions encoding structured information. Even then, decoding may prove challenging. An engineering signature from a non-human technology might not map to human conventions of modulation, timing, or coding. Alternate outcomes are possible and scientifically valuable. Atlas could represent an exotic class of interstellar fragment, a body whose history of irradiation, processing, and shock interactions produced properties we do not currently model. Studying such a body would still revolutionize our understanding of interstellar chemistry and physics. For now, the global observation campaign continues. Space agencies coordinate observation windows. Simulation centers run models across parameter spaces. Amateur data streams augment professional archives. The process is a worldwide scientific sprint, combining classical scrutiny with modern speed. When conclusions are reached, they must come with rigorous statistical framing. The public deserves clarity about uncertainty and evidence strength. If claims are strong, international bodies, space agencies, the UN Office for Outer Space Affairs, and scientific unions should be involved in transparent dissemination, even if the final answer proves less dramatic than early speculation. This episode will be a triumph of coordinated science, faster pipelines, more agile collaborations, and better global observatory networks. We will be better prepared for future anomalies. For now, keep watching. Atlas may pass into the dark and never return, or it may leave a trace of signatures that rewrite our textbooks. Either way, the event will stand as a milestone in human curiosity. Tonight, under a cold sky, remember that knowledge advances by measured steps. When observation, skepticism and imagination align, extraordinary claims are tested and sometimes confirmed. Atlas is one of those rare tests. It asks for patience and rigor, not for surrender to certainty. If it proves artificial, our response will shape centuries. If it proves natural, our models will deepen. Either result will enlarge human understanding. This is the hour when scientists race to answer a single question. Is this visitor a product of nature's strange chemistry, or a crafted object passing through our neighborhood? The coming days will supply the data, and whatever those data say, we will have met the challenge with the tools that built modern science: careful measurement, transparent debate, and collective curiosity. Watch the skies closely. The universe has presented a puzzle. How we solve it will tell us as much about ourselves as about the object among the stars. Stay curious, stay vigilant, and remember that sometimes the most important questions are the ones we never expected to ask.